Every night, as twilight deepens and the sky fills with diamonds, we gaze upward at the stars. They seem so close, their light shimmering just out of reach. But the truth is, they're unimaginably distant, so far that even starlight takes years to reach us, whispering tales of worlds both ancient and unknown. But every so often, among the countless suns and planets, there's a flicker, a change that captures our attention and stirs our curiosity. These are the moments when the universe reveals its most intriguing secrets, challenging our understanding and fueling our dreams. Now, let's turn our attention to one particular star, KIC 8,462,852, more popularly known as Tabby's star, located approximately 1,500 light-years away in the constellation of Cygnus. It appears to be a rather ordinary yellow-white dwarf star similar to our own. However, in 2015, this seemingly unremarkable star became the center of an astronomical mystery that continues to baffle scientists even today. It all began when NASA's planet-hunting Kepler Space Telescope made an unexpected discovery while observing KIC 8,462,852. At first glance, the star appeared to be dimming and brightening in a way that was not easily explained by any known astronomical phenomenon. It seemed as if something was passing in front of the star, but the dips in brightness were not regular or periodic as one would expect if it were a planet or comet. Instead, the dimming was irregular, unpredictable, and at times dramatic. With the star losing up to 22% of its brightness, this was a level of dimming that could not be accounted for by any known celestial object or event. To make matters even more perplexing, the star appeared to be fading gradually over a period of decades. According to archival data going back almost a century, Tabby's star had dimmed by roughly 15% since the early 1900s. All of this presented a cosmic enigma that has continued to captivate astronomers and stargazers alike. The first question that arises is, what could cause such irregular and substantial dimming in a star? Astronomers immediately ruled out the possibility of a planet as the culprit. The dips were too deep and erratic to be caused by a planetary transit. They also dismissed the possibility of a nearby supernova explosion, as there would be other signs, such as an increase in the star's brightness followed by a decline. Moreover, no supernova was recorded in the region during the observed period. Comets were another suspect, but their presence would have left an infrared signature due to the heat generated by their disintegration in the star's atmosphere. This was not observed either. As astronomers grappled with this puzzle, they explored the idea of dust clouds, which could explain the irregular dimming pattern and the gradual fading of the star. However, dust alone could not account for the rapid and intense dimming events. This led some to speculate that the dimming might be caused by an accumulation of dust on the star's surface, which could explain the long-term fading. But this theory too had its limitations, as dust would typically scatter light in a predictable manner, whereas the dimming of Tabby's star was highly erratic. Another fascinating hypothesis, given the futuristic nature of the phenomenon, is the idea of artificial megastructures. Imagine a massive, perhaps even colossal artificial structure built by an advanced alien civilization to harness the energy of the star. Such a megastructure could plausibly account for the irregular dimming pattern. But this is firmly in the realm of science fiction, and there is no concrete evidence to support it. But wait, what about the archival data showing a century-long decline in the star's brightness? This piece of evidence added another layer of complexity to the mystery. How could a star be slowly dimming over such a long period? This observation hinted at the possibility of a physical alteration in the star itself, such as an increase in its size or a change in its chemical composition. However, such changes would have profound implications for stellar physics and would require further observation and analysis to confirm. This is where the story takes an intriguing turn. In 2017, new observations shed some light on the phenomenon. The dimming was found to be stronger at blue wavelengths than at red, indicating the presence of dust particles smaller than about a micron. This finding provided valuable insight into the nature of the dimming agent, suggesting that it was not smoke or haze, but rather incredibly fine dust particles. This observation lent credence to the dust cloud hypothesis, but it also posed new questions regarding the origin and composition of these particles. So what exactly are we dealing with here? Is it a swarm of comets? A cloud of dust, or something else entirely? Could there be an artificial element at play? Well, the truth is, we don't have a definitive answer yet. What we do know is that the dimming of Tabby's star is one of the most intriguing astronomical phenomena observed in recent times. The study of Tabby's star has not only captivated the scientific community, but also the public imagination. In the wake of the 2015 discovery, the star became a subject of widespread media attention, with headlines speculating about everything from alien megastructures to comet showers. While such theories are fascinating, they highlight the importance of relying on scientific evidence and rigorous analysis, rather than sensationalism. In response to the public interest, SETI researchers turned their telescopes toward Tabby's star in an attempt to detect any signs of intelligent life. However, no radio signals or other evidence of extraterrestrial communication were found. Despite the lack of concrete answers, the mystery of Tabby's star continues to drive research and innovation in the field of astronomy. Astronomers are continuing to observe the star and analyze the data in search of new insights. Advanced telescopes and instruments are being employed to study the star's light in greater detail, hoping to unravel its secrets. Moreover, the mystery has inspired theoretical work aimed at explaining the unusual dimming phenomenon. Researchers are developing sophisticated models to simulate the behavior of dust clouds, comet swarms, and other potential causes of the dimming. As these models are refined and tested, they will provide a deeper understanding of the physical processes at play. Beyond the scientific pursuit, the enduring fascination with Tabby's star reflects humanity's innate curiosity about the unknown. The idea that there might be something extraordinary out there waiting to be discovered captures our imagination and inspires wonder. Whether or not the star ultimately proves to harbor anything out of the ordinary, the journey of exploration and discovery is a testament to the human spirit of inquiry. As we continue to gaze up at the stars, stories like that of Tabby's star remind us of just how much we have yet to learn about the universe. They inspire us to push the boundaries of our knowledge and to explore the cosmos with an insatiable curiosity. Who knows what other wonders and mysteries await us among the endless expanse of the stars? So next time you find yourself gazing at the night sky, remember that each twinkling point of light holds its own tale of cosmic intrigue. And just as Tabby's star has captured our attention, there may be other celestial bodies out there waiting to unveil their secrets. The universe is vast and enigmatic, and there is so much more to discover. With that, we come to the end of our journey through the enigma of Tabby's star. If you enjoyed this video, you don't forget to leave us a like and subscribe to our channel for more mesmerizing explorations of the cosmos. And if you have any thoughts, theories, or ideas you'd like to share about this captivating phenomenon, please feel free to drop them in the comments below. We'd love to hear your perspective on this intriguing mystery. Till next time, keep looking up and keep questioning the stars. Who knows what wonders you might uncover?